Hi everyone, my name is Fareez Irwan by FIRDAUS. I'm studying at the Unique MSI. Okay, let's proceed. Today we're dividing into a LabVIEW to build a practical simulation for beginners. The goal is to show you how easily it is to create a working mathematical model for two systems, a fluid flow system and a thermal system. Okay, we'll be setting up a user interface with the tab control to switch between the two systems. The user will define input initial and resistance and select between step input or impulse input. We will display the result using visual indicators like a classic tank and thermometer. Okay, as you can see here in this question, maybe bigger it. The most important part is implementing safety. The program will be prompt a user to set up maximum temperature and head limits. We will include the logic to show a warning if values exceed 70% of a maximum and automatically stop and reset the system if the maximum limits are reached. Let's start building. Okay, if you can see here, I create a new blank VI. Follow the following context. Okay, after open the blank VI on LabVIEW, open the function palette and find the prompt user for input, and then at the input name part, let's put the head and the temperature. For the temperature, I will put the C in bracket, and for the head is M. Okay, done. For the message to display, I will select the maximum values. So from this, we can set their boundaries without messing with the block diagram. Okay, and then open the function palette, go to the silver category and pick numeric, and then choose the numeric indicator. I will name it as a temperature max, and then copy another and put it at the bottom it and name it heat max. Okay, now move out to the block diagram. Clearly pop up what we added at the front panel. Okay, let's just rearrange it and connect it using a wire. Make sure it match their name for sure. Okay, back to the front panel. Find a tab control at the control palette and put it on the front panel. For the first tab, I will name it as a fluid system, and the second page second tab is a thermal system. So it matched already from the block diagram. And then, if done, find a numeric control in a silver section. Make sure each tab require 4 numeric control. First numeric control, I will name it as a capacitance, C in bracket. Second numeric control, it will be a resistance in bracket R. Third numeric control is a temperature input in bracket U. And the last numeric control is initial temperature, which is theta. Okay, let's move out to the block diagram. Let's rearrange these fellas. Oh, I forgot to put a fluid system numeric control. Okay, first of all, it will be a magnitude in bracket QI. Okay, let me just copy it first. The The second box is, I will name it as a initial head, which is H in bracket. For the top box is resistant in bracket R. And lastly is capacitance as usual, C in bracket. Okay, let's move on to the block diagram. I will arrange it so it cannot be a messy stuff. Okay, go to the control palettes and choose a thermometer from the modern section. And then right click on it and search for visible item and click the digital display. Okay, move up to the fluid system and search for a classic tank in the classic section. I will enlarge it. As usual, right click visible item and then display. Okay, let me just rearrange this stuff. Go to the control palette, to the classic section, boolean, and search for the horizontal switch. Okay, to know which side it is, we will proceed to label it out each side. First, we need to rename it. Put a select input type. Okay, for the left side, I will put a step, and the right side, I will put a impulse. Okay, match with this circuit. I will put it as a group so it wouldn't go anywhere when I drag it, and then put it on the tap control. Same as a thermal system, don't just put on the fluid system, put it on thermal system. Okay, as usual, I will rearrange it. Okay, after done, add a case structure and insert the fluid and thermal contents inside the case structure. Don't forget to connect the tap control to the case structure so it won't automatically back up from the front panel. Okay, and then drag the while loop surround the case structure, and then after that I will pick a timing and then put a weight. I will put it 200, which is 2 milliseconds. And then put the case structure inside each tab. So this case structure inside this case structure represent a switch symbol in the front panel. So make sure you need to connect it with a wire to the switch, horizontal switch. Okay, here is simply I will draw an equation for the fluid as well as for the thermal system, and I have just connected it with the input, so you can also do something if you are like most morally used to of it, like a MATLAB or like something, then you can use a formula node, and then here you can and just define your input and add an input, and then you can define as a temperature input as a whole name, then it will take as a temperature input. Okay, after all of this arrangement, make sure you need to connect the thermometer and the tank into the second case structure alongside with the smallest case structure. And then let's find the flat sequence from a function palette, and then drag it all the way around all of this stuff. Right click and click the add frame before, then drag the prompt user for input into that frame. Okay, done. Okay, and then add another frame at the after, drag it, and so I'm going to create a method via default values, reinitialize all the default. I'm going to do this as a reference so that after once we have completed all this system, all the values will be reinitiated or reset to zeros or their initial level. Alright, back to the prompt user for input. Right click on the temperature, create property node and values. So from there, just drag it under there. It will pop up after you click the values, and then do the same at the heat max. I will gonna do the same spot as the temperature max. Okay, so now one more thing is in here we have to show if the maximum, if they are exceeding the 70% of maximum value, then we need to show the warning message, right? For the purpose, what I'm going to do in here, I'm going to do a poverty node value similarity to head create poverty node value. I'm using this divide function. I can also say I will use the multiply function. I will multiply that with 0.7 since we are considering just only that 70% of the value, right? And I will use a comparison and then select function in here. I will make a copy of it, and then I will use a select and then in here as well. So I will use a string constant. For false, I will say here as a term. System, I could reduce its size so it will fit within the screen. I could give it an input and similarity as a false system. In here similarity, I will make a copy of it, and here this time I will say fluid system, and here I will say I will call it maximum and maximum head, right? I will again connect that in there. So now I have a 2 input, but still I want to show it on one output. Okay, move out to the front panel.